All right, so I was falling down a Wikipedia rabbit hole last night, and I found something that kind of broke my brain. You know how we just assume we know what stars are? Like big balls of gas?
I mean, yeah, hydrogen and stuff, right?
Well, we know that now. But for basically all of human history, we had no clue. And the way we found out is honestly a movie script. It's all thanks to this woman, Cecilia Payne-Gaposchkin.
Wait, I've heard of the big names like Hubble or Einstein, but I've never heard of her.
And that's the problem. Back in the 1920s, the experts believed stars were made of the exact same stuff as Earth. They thought if you dug up a scoop of the sun, it would be mostly iron and silicon.
To be fair, that kind of makes sense. It's all we had to compare it to.
Totally. And they had proof. They used spectroscopy. You know how a prism splits light into a rainbow? Well, you can do that with starlight, but you will find dark black lines across the rainbow. Every chemical element has a unique dark line, like a fingerprint.
Okay, so they saw the fingerprints for iron, and they were like, case closed, it's a giant iron rock in the sky.
Exactly. But Cecilia was a student at Harvard. She actually had to move there from England because Cambridge wouldn't even give women formal degrees at the time.
Wait, seriously? She did the work, but didn't get the piece of paper?
Yup. So she goes to Harvard, looks at those same fingerprints, and realizes everyone is reading them wrong.
How do you misread a fingerprint?
Well, before her discovery, if scientists saw a weak signal for a specific element, they just assumed it meant there wasn't much of it in the sun. But Cecilia applied new physics theories about heat and atoms. She realized that for an element to leave its fingerprint, that black line, the electrons inside the atoms have to be stable. Imagine an electron holding up a tiny mirror to catch the light. If the star is too hot and the atom is moving frantically, it can't hold the mirror steady. We lose the reflection, and we lose the black line.
Okay, that explains why the line is weak. The heat messes it up. But if the signal is distorted, how can you possibly calculate how much of that element is actually there?
That is the million-dollar question. And it's exactly where her math was pure genius. She didn't just count what was visible. She calculated the ratio between what shows up and what is hidden. And once she pulled back the curtain, she realized that stars are actually 99% hydrogen and helium.
Whoa! I'd heard we're made up of stardust. I guess we're the weird part.
Precisely. We're the oddballs. But when she put this in her PhD thesis, her advisor told her she was wrong. He basically pressured her into saying her own discovery was probably a mistake, because it went against what all the big names believed.
That's infuriating. So she makes one of the biggest discoveries in astronomy, and they tell her to hush. If some famous professor, like her supervisor, had presented those same numbers, do you think they would have dismissed him so easily?
Honestly, probably not. They might have called this idea bold or revolutionary. But for a young woman in the 1920s, it was easier for them to assume she made a mistake than accept she had outsmarted the establishment.
Wow, that's just unfair to her and bad for science. It's crazy to think that we're out here building massive new observatories to observe the invisible. But back then, we got stumped on what regular stars were made of because people couldn't look past their own biases.
Totally. It actually took years for them to admit she was right. And even after she taught at Harvard for years, it wasn't until 1945 that her courses were finally recognized in the catalog.
1945. That's 20 years after her discovery.
Exactly. She eventually became the first female professor at Harvard, but she had to fight for every bit of respect. It turns out that changing human biases is at least as difficult as understanding the composition of the universe. Luckily, we can now continue studying the universe, standing on the shoulders of scientific giants like Cecilia.